You thought it was so easy, didn't you? Well, you're right. It's still easy stuff. To first understand Suvat, which is the beauty of this chapter, we need to go through some graphs. Our first graph plots distance traveled against time elapsed. You might notice that the gradient changes along the journey. As you may recall, distance over time equals speed, so if the gradient is steeper, then the object is traveling at a higher speed. Naturally, a gradient of 0 means that the object is stationary. This sounds too simple to be good. Journeys in real life have very few lines that are straight and simple. Here's some data I collected while riding with Remy on the morning. It's all over the place, and how am I supposed to calculate anything from that? Couldn't she have been more steady? Sorry. Turns out you can do so much from this, like calculating instantaneous and average speed. Let's go back to the graph. The actual definition of instantaneous speed is the rate of change of position with respect to time. Does this ring any bells? Yup, dy to the dx, baby.
It's ds over dt.
Oh, shush, I know what I'm talking about, which is differentiation. That's right, when you differentiate distance in respect to time, you get speed. My fellow classmate, Angelina,
Don't call me that.
will cover this in detail in her upcoming playlist.
What?
Moving on swiftly. The instantaneous speed is also the gradient of our graph at the instant in the moment. This means the speed during a particular point on the graph. Now for the calculation. Find the instantaneous speed of Remy's bike at 600 seconds. Pause this video now and try it out.
To start, find the point at 600 seconds and carefully draw a tangent there. You're now going to get the gradient of this line. You know, the y2 minus y1 over x2 minus x1. In this case, it will be 1000 over 300, and that'll give you 10 over 3 meters per second, or 3.3333, you get it. Easy! Now for the average speed. Average speed is the speed calculated over the entire journey without regard to variations in speed. Basically, you get the point at the start and the end of the graph and connect them and get the new line's gradient. So that's the end of today's video. Remember, everything I said today also applies to instantaneous and average velocities. Just change the distance to displacement and include directions when coding these measurements. Thank you for watching and see you next lesson.